name is Ricardo Sosa, and his name is Carlos Garnica, and today we're going to explain temperature to you. First of all, what is temperature? Temperature is the measurement of motion of molecules. So there's three types of state in a mass. There is the three that you probably know, is solid, liquid, and gas. Solid, the difference between these three is that in solid all the molecules are stick together. They are really close to each other. Liquid, they're still close but not that close to be solid. So they will go like this. And in gas, all the molecules are far, like, they're really apart. You have one molecule here and the other one will be here, the other one here, here, and here, like really apart.
If we are going to talk about temperature, we also have to talk about heat. And we have to know the definition of this. Heat is the thermal energy stored in a certain mass.
So I will explain to you the three types of measurement of temperature, like the three most common. I will just talk about two now. That is Fahrenheit and Kelvin, and Celsius. Sorry. So you usually will see it like this in scale. Here you have Celsius, and here you will have Fahrenheit. Here you have like 100 Celsius, and you will start in 32 Fahrenheit up till 212. Why is this? So you have your scale here, and in this intersection, like, you have the equivalence that 100 Celsius equals to 212 Fahrenheit. So the formula should be looking like this: Fahrenheit equals to 9/5 Celsius plus 32. And if you take off the Celsius of this formula, you will get also the formula to obtain Celsius. That is, Celsius equals to 5/9 multiplying Fahrenheit minus 32.
And finally, we have Kelvin, that we know it as 273 plus your Celsius.
So that will be the three most common measurements of temperature. And I will explain to you with a little, like a quick exercise that it goes like this. During a 24 hours period, a steel rail varies in temperature from 20 degrees Fahrenheit at night to 70 degrees Fahrenheit in the middle of the night. It wants you to express this range in temperature in degrees centigrade. So it's really easy. We only have to convert the Fahrenheit to Celsius, and then you will see. So you have the time, that is a period of 24 hours. You have your temperature, that is from 20 degrees Fahrenheit to 70 degrees Fahrenheit. So the only thing you have to do is use your Celsius formula. So it will be Celsius equals to 5/9 for 20 degrees, that is this first, Fahrenheit, minus 32. This equals to minus 6.66 grados Celsius. And the other one will be the same, but now we have to obtain this one. So it will be 5/9 multiplying 70 grados Fahrenheit plus 32. And this will give you 20.9 grados Celsius. So the only thing you have to do to take the range is subtracting. It will be range equals to 20.9 degrees minus 6.66 grados Celsius. And this will give you an equals of, well, here you have the minus also, okay? So it will be a sum. So it will be 27 point 5, am I correct? Grados Celsius.
Well, now I'm going to do another example, very easy and very basic. The problem says the melting point of lead is 330 degrees Celsius. What is the corresponding temperature of Fahrenheit scale? So we just have to convert from from Celsius degrees to Fahrenheit. And we know the formula of Fahrenheit, that is 9/5 Celsius plus 32. So we have the problem, and we just make this. That will give us 626. So for this problem, you can see that it's very basic. You just have to apply one formula, and that's all.
We're going to continue with temperature. Jose Eduardo Garnica and me, Pablo, we're going to explain thermal expansion. Thermal expansion is when you apply heat to an object, and this object changes its original mass. Jose Eduardo is going to explain us three types of
thermal expansion. All right. So for you just to picture in your minds, we have three types of thermal expansion. The most basic one is the one you can see everywhere, basically. So it's the linear expansion, right? For linear expansion, we have a formula which is this one. The change in length is equal to alpha times the initial length, right? Times the change in temperature. Why? Because we have an initial length, then we have an initial temperature and a final temperature due to the power of heat that is exerted on the object, and alpha is just a variable, right? So then we have the superficial thermal expansion. Superficial, right? This one has to be with the area, right? So the change in area is equal to this times the thermal length times the change in temperature. As equal, we have an initial length and the change in temperature. Then we have the volume, which is the last type of thermal expansion, and this is gonna occupy the change in volume, right? So we have beta times the initial length again. The initial volume, and this time is going to be the initial area, and here is going to be the change in temperature again. So just for you to understand this better, I'm going to be quickly. We have alpha, we have this one, and we have beta. This one, alpha, is for the linear, and then for the superficial, this one is equal to 2 alpha, and for the volume, as normally, the volume equals 3 alpha. Okay?
Right, so I'm going to explain an exercise of linear thermal expansion for you to imagine an example of this. Well, the exercise told us an iron pipe is 60 meters long at room temperature in 20 centimeters. So the length initially is 60 meters. The temperature initially is actually 20 centimeters degree. They asked us about the rate of change of length, about the length, and we have the change in temperature. The final, it's actually 100. Final, it's equal to 100. Then the rate of change of temperature is equal to 80. Alright, so we just have to apply the formula that Eduardo told us. So we have the change of length equals 1.2 x 10 to the minus 5 1 over. Well, this is actually the sign that is alpha, and this is the iron one. So this is expressed in the exercise. We don't have to look for it. Then we multiply times the length times the rate of change of temperature, that it's 80. And this is equal to 0.057 meters, and this is going to be our answer. Thank you so much.